Hello, everyone, and thank you for joining us for the webinar today. My name is Ben Hutchins, and I am part of the marketing team here at Inovis and Autodesk company. Today, we'll be showcasing Project Resilio, the case study of Amsterdam's adaptive smart network of blue-green roofs. For those of you who joined us live for this webinar, you will notice that this recording is slightly different. Unfortunately, the webinar recording file was corrupted, so we would like to offer a huge thanks to our guests from WaterNet for making themselves available to re-record their presentation today. So let me introduce you to your experts. Firstly, we have Casper Span from WaterNet, the water company for Amsterdam and surrounding areas. Casper is a policy developer for climate adaptation. He has a strong focus on the external dialogue needed to involve urban stakeholders to tackle the challenges of climate change. The Amsterdam Rainproof Programme is the vehicle that addresses these challenges, creating the awareness and delivering solutions for more than 10 years. Casper is especially focused on the interaction between the public and private realm in the complex urban landscape to find feasible climate adaptive solutions within the scope of the squeezable sponge city. The Resilio project with the blue-green roofs was a significant milestone in Amsterdam's mission-driven ambition towards a climate-adaptive city. Next up, we have Jura Singer, asset analyst of the urban wastewater system at WaterNet. For the last 5 years, she and her colleagues have been working on climate adaptation for the city of Amsterdam. One of the main tools of this analysis is InfoWorks ICM, used to analyze flooding risks and create future-proof designs. Your host today is our innovation manager, Ruth Clark. Ruth is a civil engineer with over 25 years experience working in the water industry. Ruth rejoined Inovis in 2022, having previously worked for the company between 2000 and 2016 in both technical and commercial roles. Throughout her career, Ruth has been involved in a wide range of projects from flood risk assessments and flood forecasting systems to smart water IoT platforms and treatment optimization. Right, let's start the show and learn more about Resilio. Ruth, over to you.
Thank you, Ben. Good morning and a very warm welcome to the webinar today, which explores the impact of implementing blue-green roofs in heavily urbanised areas. We'll see the drivers behind the project and indeed how that impact has been assessed. Before I pass over to Casper and Jura, I'm first going to give a brief introduction to Inovis for those of you who are not familiar with what we do. Inovis is a software company that's been in the business of providing software solutions to the problems being faced in the water industry for about 40 years. The areas in which we work cover the entire water cycle. So we provide tools to help users design and analyze water, wastewater and stormwater networks. We provide tools to help manage those assets all the way from proactive planning through to the reactive maintenance. And we also provide tools that work with near real-time data for operational decision making. As many of you might be aware, Inovis was acquired by Autodesk approximately 2.5 years ago. And at the bottom of the slide is an indication of why there is such synergy between Autodesk and Inovis. So when we talk about the design of assets using Inovis tools, we're generally talking about sizing of pipes or tanks or pumps or even rain gardens, for example. But that's just one part of any project. So for all projects involving water, there'll be a much wider view, other services, roads, rail, etc. So being able to become part of the wider Autodesk ecosystem is really exciting. I'll stop now, and without further ado, I will hand over to Casper and Jura, who will provide you with the interesting stuff that you've all signed up to listen to.
Thank you, Ben and Ruth. I won't introduce myself any further. Thank you for that, Ben. But it's great. It's good to emphasize the special role of WaterNet in the Amsterdam environment concerning water management. We produce drinking water, distribute it. We bring the sewage to the sewage treatment plants, and we have responsibility on water quality, quantity, and safety. So we work in all aspects of the water cycle for the Amsterdam area. Today we will tell you about our story on the Resilio project. Over here you see a depiction of the blue-green roof concept, because that's where it's all about. And in fact, and it's good to have that picture in mind, it's a classic green roof system, elevated with a crate system underneath that brings significant water storage capability, and additional valve system so we can control the water level in the water storage underneath the green roof. Before I'll bring more about the Resilio project, it's good to know that it's developed in a much broader context. It's not, Resilio was a project that took 2.5 years, but we were working on the blue-green roof concept for over 10 years now. And that started with our Amsterdam Rainproof program. It's a network-based open platform to involve all stakeholders in the city on the awareness and the actions and the collaboration we need on climate adaptation issues, especially extreme rainfall. We're working with the knowledge institutes, financial partners, garden centers, citizen initiatives, everybody who has something at stake and who hasn't in the climate-proof city. In the 2013, we had a dialogue with the green roof sector on when is a green roof blue. And that in essence brought us new ideas on the blue-green roof systems, because the classic green roof doesn't do that much for extreme precipitation and sponge city concepts. We developed a crate system with substantial water storage, up to 60 millimeters or even more, if you like. And in the end, we invested in valve systems that could be controlled remotely. So we were able to manage the water and interact on, for instance, the high resolution weather forecast. From that moment on, we learned that when you invest in a roof and create a valuable roof environment, it attracts a lot of other functions. Especially the dynamic quantified water storage made it feasible to create permits and value the water storage on the private property from a public perspective. Since then, we have been developing policy instruments, the community working together on this concept, because there is an enormous complexity in the governance, the different roles and responsibilities, and that's what we like to share with you. All the spin-off since then summarized made it visible that it's relatively easy to implement blue-green roof or enhanced roof systems on new built new buildings. One of the policy instruments that helped us with that was the rainwater ordinance. Nowadays, in Amsterdam, every new building or a big transformation is obliged to store 60 millimeters of water on its plot with a certain release, 1 millimeter per hour. So it has an empty storage capability in time for other rainfall, or a dynamic control system. It also learned that it helps reduce extreme rainfall events or the effects of that on the public space. But it also helps in other climate change issues as heat stress. It helps to cool the city. The cooling power of water is enormous. And of course, to overcome droughts, because those droughts can stress the green city we're aiming for. Water availability is key. And in fact, we can say that we work with so many partners, so many roles and perspectives that we were in an ecosystem approach, as I like to call it, as an ecologist. Nowadays, mission-driven is more the recognizable concept on blue-green roof systems in our sponge city ambition. And that led to Resilio. Small sidestep is the development of the multifunctional roof space concept. And that also went national with our national roof plan, a collective of over 60 partners with governments, commercial partners that are aiming on creating value on our roof, because it's a barren landscape where we can bring so many functions together, from water storage to biodiversity, energy production, as well as social functions that are depicted by the different colors in this scheme. And in 2018, we started the Resilio concept. It was a reused, earlier failed application. So we had a lot of concepts in place already. And it was successful, and then we had to make it happen. It was a very generous financial subsidy from the EU, almost 5 million, and another million had to come from all the partners involved, so the 80% was covered. We already learned that new buildings are relatively easy to bring the blue-green roof concept toward. The existing city is the real challenge. And in Amsterdam, we have social housing corporations who own over 40% of the real estate stock in the city. And that made us that we focused on the social housing corporations to cooperate in this Resilio project. Here you see all partners involved: free housing corporations, the knowledge institutes with researchers from the Free University and the University of Applied Sciences of Amsterdam, roof partners as Rooftop Revolution, an NGO that helped in the communication, Metropoler, who is the developer of the smart valves. And we worked in a classic concept of work packages to create the whole project. This is the infographic we used for the interaction with the public, because it was essential to involve the people who are renting at the social housing corporations in creating a more attractive and valued roof landscape. And that helped during Corona times. It was harder because a lot of things had to happen online with a more complex involvement, but we were able to reach out to that public with the images as these. These are the realized roofs. It was in total over 10,000 square meters. In green, you see the social housing roofs that were developed. in orange, an additional grant scheme was created to also bring these roof concepts to other partners as well. And in blue, the so-called innovation labs that were easily accessible and showcasing the blue, green, yellow and other functions concepts, so where we can bring delegations and other interested parties to and tell the stories. From a water management perspective, this image brings the story very well. We created a decision support system where a made-to-measure advice to all the smart valves could be created. Working with the weather forecast, macro water management data, but also building specific information about the demands of the roof owners, the extra usages they were expecting from the water storage. And so you create a model where you can squeeze the sponge that the blue-green roofs bring on the city landscape in such a way that you can store the water when droughts are coming, or create extra storage capability when high precipitation volumes are to be expected. From here on, I give you Jora.
Yes, thank you, Casper. I'll just take control of the screen right now. So what we did in one of the work packages, I did this together with one of our colleagues, Anne van Rijn. We looked at what would be the impact of using these blue-green roofs on a larger scale. So what would be more the system impact you can make from incorporating the blue-green roofs on a neighborhood level. So we looked at two neighborhoods in Amsterdam, being the Slotermeer and Rivierenbuurt neighborhoods. I'll come back to that later. Trying or aiming to answer two main questions, being which roofs are suitable for blue-green, and what would be the hydraulic and hydrological impact of blue-green roofs. Looking at what would be the impact for flood risk using those roofs, but also what would be the impact of a so-called second wave on the system once these roofs are discharging after the precipitation event. So the suitability analysis is as follows. We looked at 4 different factors. The size of a roof is important in order for it to be cost efficient. The slope shouldn't be more than 8 degrees in order to install a blue-green roof. Construction year has to do with the type of material which is used to build the houses. From the 1960s or maybe even from the 1950s in Amsterdam, the houses were built more with concrete instead of wood, resulting in a larger carrying capacity, which is suitable for installing an extra topping, extra weight on the roof. And as Casper already mentioned, we looked at property of housing corporations as they were part of the consortium, and so part of the study for Resilio. But when you look at private ownership as well, there's of course a larger fraction of the city which is part of this suitability. Those 4 factors resulted in 4 different scenarios. A baseline scenario with no blue-green roofing, the locations of the Resilio roofs, and then the 2 construction years from the suitability analysis. So these are the 2 neighborhoods we looked at. On the left, you can see the Slotermeer neighborhood, which is relatively newer, with more open space, and it has a separated sewer system. And in pink, the location of Resilio roof is shown. And on the right, you can see the Rivierenbuurt, which is a slightly older neighborhood having a combined sewer system, and it's more densely populated. In yellow, you can see the areas which are the high flood risk areas, and I will come back to that a little bit later on. So when looking at all the roofs in those two neighborhoods which are suitable for blue-green, it results in, well, it's roughly 70% of the two neighborhoods. You can see them here in pink. And those are the roofs we used in the scenarios we've run in the models. And we used two different types of programs. Anna, our colleague, has used SWIM to look at the 1D component. So that's more used for the precipitation of 20 millimeters per hour, which is our standard for our rainwater system. And she looked at the flooding at the manhole locations. And we did a 2D analysis as well, using InfoWorks integrated catchment modeling, using the sewer system, but also the surface runoff. And we calculated that with our so-called rainproof precipitation event, which used to be 60 millimeters per hour at the time of this study. It's just recently been, it has increased to 70 because it is a precipitation event which occurs every 100 years. And due to climate change, that's for the city of Amsterdam, for the Netherlands, it has increased from 60 millimeters per hour to 70. And with that analysis, we looked at the volume within those high-risk flood areas. So from the 1D analysis, you can see that in the Slotermeer neighborhood, there are a couple of locations where there's flooding at the manhole locations. And when modeling again with the Resilio roof, you can see there's a reduction in those flood volumes. Just with one roof, it is a reduction of about 4%. But looking at the suitability of roofs which could be blue-green, you can see a reduction of over 60% of flooding in those manhole locations. In 2D, you can see here the maximum water depth during a calculation with this 60 millimeters per hour event. We use as a standard that there shouldn't be any risk of flooding at the houses, so at the property locations, but also there's a standard for the streets themselves, because when the maximum water depth is higher than 25 centimeters, so you can see that in this kind of slight pinkish light red, then it wouldn't be accessible anymore for emergency services. So that's the situation we want to prevent. And the locations where this occurs, you can see that in purple here. So, and the Resilio roof is here in green. So the effect of using blue-green roofs for those extreme cases is with just the one roof, it is a really slight change. But when using all the roofs, you can see that there's a reduction of volume of a couple %. In the De Vierdebuurt neighborhood, you can see a similar result, maybe 3% of volume reduction within those flood risk areas. So what we can conclude from this is that in terms of suitability, when looking at social housing, there's a maximum of about 70% of the roofs which could potentially be used as a blue-green roof. Of course, when taking private ownership into account, this would be a much larger suitability. And as Casper already mentioned, we have a rainwater ordinance for new build areas, and there all the roofs should use a storage of 60 millimeters per hour. So you can see in those areas, there's really a large impact on what flood risk you have left in the public space. And we have to use much smaller measurements there. So from the results of the modeling, you can see in 1D, there's really large effect of flooding at the manhole locations, over 60% decrease. In 2D, it's only a couple of % in those extreme cases. And the impact is much larger when the roofs are located more closely or more locally to those flood risk areas. And as I mentioned, we looked at those second wave occurrences as well, like what would be the impact of discharge from those roofs once the precipitation event has passed, but there is no risk of flooding due to this second wave. So that's not something we can worry about. So I think we can conclude that blue-green roofs are really a part of the solution. They help, they store water during those peak moments when we really need it, but it should always be something we use in combination with other types of climate adaptation measures. And then I'll give the word back to Casper.
Thank you, Jura. And here I am proceeding with the last parts of our presentation. The Resilio project already ended 2 years ago. Although we have at least the maintenance ambition of another 5 years to make everything, to keep everything working, and that's going fine. But since then, we're working hard on the dissemination of our knowledge we like to share with other cities. And we see that it's quite successful. We see a lot of interest for interviews, webinars, such as this one. Conferences where we or one of the other partners tell stories and bring our concept of the squeezable sponge city to the broader public. This is already a bit older, this sheet, because it refers to the Amsterdam International Water Week 2 years ago. Last week we had again the International Weather Week with the Aquatech, and also there was interest in the micromanagement capabilities of storage systems. We see that it's a growing industry, and we are proud that we could play a part of it. What I finally would like to give you is some of the lessons learned from Resilio. They might be recognizable, but it's the creating an innovation is relatively easy, but implementing it on a broader scale is complex because it has to battle a lot of the existing regulations and cultures. Business case, water is cheap in the Netherlands, so storing water and reusing it for green infrastructure is very difficult to create a positive business case towards, and business cases tend to focus on the hard currency profits, and we see that a lot of these ambitions blue-green roofs can bring are built upon softer societal benefits, and that's where it's more difficult to create that business case. It's essential to work with the investment cycles we see in the city from other sectors like solar or insulation, maintenance, renovation of buildings, because if you go contra that rhythm, it will be too expensive. On the positive side, we see that investing in a blue-green roof system has many benefits because it creates as we call it, a Lego landscape on the roof, where you can add very easily other functions on the whole crate systems that form the basis for these blue-green roof systems. Nowadays, we're working on an integral roof plan in Amsterdam because we see that coordination and stimulation on that roof landscape is essential to find the right mix for society and focus on area-specific challenges. These blue-green roofs, as Jura explained, have especially positive effects in areas where there are already wet spots, rainwater nuisance problems. So bring your blue-green roofs to those spots. We know that the governance aspect is very challenging. And I can't speak for many other countries that might be listening in, but everybody has to find its own way to implement these challenges. Some countries and cities are ahead, and that's a good thing. Others might learn, but you eventually have to find your own place, your own commitment, your own partners, and your own regulations that might work for your specific city. We close with some additional information that is shared with Inovis as well, where you can find more information about the Resilio project and everything that went on. I would like to thank you for listening in and close our session over here. Back to Ruth.
Thank you very much, Casper and Jura, for that really, really interesting presentation. It's always really interesting to understand the background and the context of projects, not just the results, although obviously the results are also really interesting. So really appreciate that. I will now pass back to Ben to end the session.
Excellent. Thank you very much, Casper, Jura and Ruth, for the webinar today. We will be sharing links to the documents that Casper has referenced in his slides. And finally, we also hope you found our session interesting and look forward to welcoming you to our future webinars. Have a great day, everyone.